is section 3.2, functions. Our objective today is to evaluate functions and complete input-output statements. Let's start with vocabulary. A function is a rule that assigns to each input value exactly one output value. A function rule is an equation that describes the function. So you also need to know what input and output are. The input is the thing being put into the function, and the output is the result we get when we put an input into a function. My little image here, we start with our inputs over here on the left. They go into whatever process that's our function, and they come out as our outputs. These are examples of function rules. Y equals 4x plus 4. I put in an x, I get out a y. D equals 30t. I put in a t, I get out a d. F equals 9/5 c plus 32. I put in a c, I get out an f. Let's try this example. Juan begins his exercise walk from his friend's house, which is 50 meters from his own house. The function d equals 3t plus 50 gives the distance d in meters after t seconds that Juan is from his own house while walking. Find the output d for the input t equals 10. This gives us our function rule, d equals 3t plus 50. It also gives us an input. So let's find our output. So to find our output, we're going to plug in t equals 10 to our function rule. Well, 3 times 10 is 30, plus 50 means d equals 80 meters is our output. Try this one. The function f equals 9/5 c plus 32 converts the temperature in degrees Celsius to degrees Fahrenheit. Evaluate the function for c equals 20. Right, to do this problem, you're going to take our function rule and our input, and let's find our output. So let's plug in c to 9/5 times 20 plus 32. Well, 9/5 times 20 is 36. You can do this by taking 20 divided by 5, which is 4, times 9 makes 36, plus 32, so that means f equals 68 degrees Fahrenheit. Try these three. Evaluate the function m equals 4x plus 4 when x equals 2, when x equals -5, and when x equals 10. So when you do these, for the first one, you should take m equals 4 times 2 plus 4. 4 times 2 is 8, plus 4, so m equals 12. For the second one, we'll take m equals 4 times -5 plus 4. Well, 4 times -5 is -20, plus 4 means that m equals -16 is our answer. And for the third one, we'll take m equals 4 times 10 plus 4. Well, I know 4 times 10 is 40, plus 4 means that m equals 44. All right, now let's make an input-output table. The function t equals 1/2 m minus 12 gives the temperature T in a container in degrees Celsius and the minutes before, at the start, and during an experiment. Use the function to make an input-output table for m equals -2, -1, 0, 1, and 2. So basically an input-output table. The left side of your table will always be your inputs. The right side will always be the outputs. You'll want to label m and t on the top of there. Your inputs are usually listed from least to greatest, going down. So let's calculate our outputs. So to do this, I do 1/2 times -2 minus 12. It's like what we were just doing, just more problems in one. So 1/2 times -2 is -1. -1 minus 12 is -13 degrees. Now let's plug in -1. 1/2 times -1 minus 12 ends up being -1/2 minus 12, which is -12.5 or 12.5. When we plug in 0, we have 1/2 times 0 minus 12, which is 0 minus 12, which is -12 degrees. For 1, we have 1/2 times 1 minus 12, which is 1/2 minus 12, which is -11.5 degrees. And for 2, we do 1/2 times 2 minus 12, which makes 1 minus 12, which is -11 degrees. All right, your turn. You're going to use the function m equals 1/3 n plus 1 to make an input-output table for n equals -1, 0, 1, and 2. Your input-output tables do not have to be complex. N is our input, M is our output. We have -1, 0, 1, and 2. This is as complex as they need to get. If I plug -1 into my equation, I get out -1/3 plus 1, which is going to be 2/3. If I plug 0 into my equation, I will get 1. If I plug 1 into my equation, I'll get 4/3, or 1 and 1/3 if you prefer. If I plug 2 into my equation, I'll get 5/3, or 1 and 2/3 if you prefer. There's our input-output table. And finally, we're going to complete this table for the function rule d equals 0.05c, where d represents the deposit in dollars and c represents the number of containers. So for the first one, we're going to plug in 6 for c, and for our d, we end up with 0.3. For the second one, we plug in 12, and we end up with 0.6. And for the third one, we plug in 24, and we end up with 1.2. That's how we would fill in our table. Here is your assignment, and there will be a quiz following this lesson.